This is number 32 on page 106, and you'll notice it says in how many ways can 5 numbers be chosen from 7 numbers 1 to 7, so that the 5 numbers have a sum which is a multiple of 4. Now, let's assume we've got the looking at the 7 numbers. 7 numbers. Now, we want to say the number of ways we can actually get 5. Number of ways is this is 7 numbers combination 5 will give you 21 ways. So there are 21 ways in which we can get the sum of 5 numbers. But then these numbers must be a multiple of 5. Now if we total all 7 numbers, the sum of those 7 numbers, it's 7 over 2 into the first term plus the last term, which is 8, and 2 will go into 8, and that gives us 28. So the sum of the 7 numbers is 28. So therefore the sum of the 5 numbers must also be a multiple of 4. So it must be able to be written as 4n. So now therefore we know that the sum of the 5 numbers cannot be 28, because it's only 5 numbers that we have to subtract from. So the maximum sum that the 7 numbers will have is 28 from our working. So this problem here is not a straightforward problem, and the easy way to do this is to take possible sums. Now let's assume now our first sum that we are taking is 24. Then it means that I must remove 2 numbers here, which gives me the sum of 4. So if I remove the 2 numbers that I can only remove is 1 and 3. I can't remove anything else. So I can remove 1 and 3. So if I remove 1 and 3, I've got 1 way. Now, can't remove anything else. So I must go down to the next multiple, which is 20. Right? Now, from 20, I must now remove 2 numbers whose sum is 8. So if I remove 2 numbers whose sum is 8, 1 and 7, and 2 and 6, and 3 and 5. So there's 3 ways. There's no other way we can do it. So now it means all the other combinations I can get 20. I will get. Then now I must take S3, which will give me 16. So it looks like 12. So I must find 2 numbers which gives me sum 12. 1 and 8, 7 is out, 2 and 7 is out, 3 and 7 is out, it's less, 4 and 7 is out, 5 and 7 is 12. Then I can go to S4 if I want to, and that's 12. So I must look at 2 numbers whose sum is 16, and that's not applicable here. So in other words, there are 1, 2, 3, 4, 5. So they wanted to know what is the number of ways in which we can get that. So obviously if I take out 2 numbers and I leave 1 and 7, that's 5 numbers intact, you can't do anything. So in other words, there's only 5 ways. That's your answer. But assuming they said, which is a much more interesting answer, in how many ways 5 numbers can be chosen from numbers 1 to 7, so that the 5 numbers have a sum which is not a multiple of 4, and then you take it, 21 minus 5 is 16 ways, which would have been a better problem. This is problem number 35 on page 107. It says in a certain town, some people were affected by the Ebola virus. In the first quarter, there were 30% who were affected by the virus, while 70% were healthy. So in the first quarter, we had 30% were affected by the virus and 70% were healthy. Now, in the next quarter, the 30% of the sick people recovered. So 30% of the sick people would have recovered, would have been 30% of 30%, which is 9%. So that is 9%, 9% which will come out of this. So in other words, it would have left you with 21%. So they would have recovered, so they would have become healthy and they would have gone on this side. So the 9% would have gone on this side. So we'll keep that in mind. Then they said that 30% of the healthy people contracted the virus. 30% of the 70% is 21%. 21% contracted the virus. So if it took out the 21 from there, it would have been 49% of them remain healthy. So here the total number that would have contracted the virus is 42%, and here 58% would have remained healthy. And the 42%, what fraction of the population? 42% out of 100 would have been 21/50, would have been sick at the end of the second quarter. This is problem number 38, which is on page 107. How many ordered pairs xy of positive integers x and y such that xy plus 5x xy xy plus 5x plus 5y is equal to 2005, and we want to know how many positive integers. Let's say we want to make x the subject of the formula here. So you got xy plus 5x is equal to minus 5y plus 2005. Then you got x into y plus 5 is equal to minus 5y plus 2005. Dividing, you got x is equal to minus 5y plus 2005 divided by y plus 5. So let's try to create a situation here where you got minus 5 into y plus 5. So that will be minus 5y minus 25. So I've added a minus 25, so I need to add the 25 on that. It'll become 2030 all over y plus 5. We've used this several times before, and now we can divide each one. So I'll get minus 5, the y's cancel off, but then I've also got plus 2030 over y plus 5. Now the question is how many pairs of positive integers I've got. So if I had to actually multiply this by, factorize the numerator by the way, so I will get 2 times 5 times 7 times 29 all divided by y plus 5. Now remember, my y, the lowest value y can have is 1 because they're talking about positive integers. Y will not be equal to 0. Now if y was equal to 0, obviously we got some answers there as well. Now if I take this part here, 2 times 5 times 7 times 29, they're all prime factors. And the number of divisors they will have is 2 to the power 4, which is 16. So we could very easily say, it'll have 16 divisors, and all we need to do is to start to say the 16 divisors, and it just works out just like that. But remember, x must also be positive as well. Now the logic here is I'm trying to just work out my own strategy for this problem. Now obviously we can't make y plus 5 equal to 2 on its own, so it will exclude one of the factors there, so 2 comes out on its own. Then I cannot take y plus 5 to be equal to 5, which means that y will become 0, and then so in other words 5 has to come out completely. Then can I take y plus 5 to be 7? If that's the case, then what will be, then I can replace y by 2, 7, and then it will work out perfectly. That's not a problem. So 7 is not a problem. So 2 and 5 individually are problems. Then the other one is this. Supposing I take 2 and 5, 2 times 5 is 10, and I make y plus 5 equal to 10, then y is equal to 5. Now we also have another problem here, is where, let's assume I took y plus 5 to equal to the entire number there. Then I'll get 1 minus 5, and I've got a problem. So I can't take that set there. 2 times 5 times 7 times 29 as a set. Then can I take 29 times 7 times 5? I will have a problem as well because I'll end up with 2. So I can't do that. So in other words, I can take 2 times. I can't take 7 times 29 times 5. And I can't take 7 times 29 times 2. So I can't take 1, 2, 3, 4, 5. So which leaves me with 11 as the answer. Right, this problem here is number 41, which says the coefficient of x to the power 99 when all those are multiplied out. Now, when you start, let's look at the possible coefficients that we have. If you take x minus 1, we'll just look at the variables that appear. So t1 is 1. X minus 1 times x minus 2. If I multiply that out, I'll get x squared minus 3x plus 2. My coefficient of x is minus 3. And if we take multiplying the next factor out, which is x squared minus 3x minus 2, I will just come back to this one here, into x minus 3. So I will get x cubed minus 3x squared minus 3x squared. So I will get x cubed minus 6x squared. So we're looking at T3, it's 6. I will leave out the minus sign. I'm just hoping that then we got x cubed minus 3x squared minus 6x squared and so on times x minus 4. So here you would get 10. T4 equals 10. So the coefficients basically are, if you look at 2, then you're looking at x to the 1. If you look at that 2, x to the 1. And if I'm considering this is the x to the 0, yes, then it will make minus 1. So we got minus 1 there, minus 3, minus 6, minus 10. Now if you look at that, those are triangular numbers, and the nth term is n into n plus 1 all over 2. Now remember, we're going to the last expression, but it's giving us a coefficient which is before that. So when we're looking at 3, we're looking at x squared. So we're looking at 4, we're looking at x cubed. So now you're looking at T100, which is 100 times 101 divided by 2. All of us know this is 5050, and since we are looking at a negative number as a coefficient, so the coefficient of x to the power 99 is minus, the coefficient of x to the power 99 is minus 5050. Now this actually concludes our DVD session on problem solving, and what I want to say at this stage is that we want to encourage you to go through all these, the booklet itself. You've got the answers at the back. Now if there are any answers which are incorrect, we would very much welcome a feedback on it. And I want to thank you for your participation in this. You will also notice that we have problems on geometry as well, but that is for your edification and preparation for the National Senior Certificate Examination. And you will notice, although we've gone above the curriculum because that's what's required, you would also be able to use this, and it is more than adequate preparation for the National Senior Certificate Examination. And I want to wish you everything of the best in the NBT test, and let us hope that you will get your chosen career and that you will achieve whatever you want to achieve. Thank you very much.